When you see these incredible structures, skyscrapers that literally scrape the clouds, airports that feel like their own little cities, do you ever just stop and wonder, how in the world did they build that? Well, it's definitely not magic. Today, we're going to pull back the curtain on the incredible discipline that makes it all possible: systems engineering. I mean, really think about it. What does it take? We're not just talking about pouring some concrete or welding a few pieces of steel together. We are talking about orchestrating thousands, maybe tens of thousands of people, juggling budgets that are just mind-boggling, and connecting an almost infinite number of moving parts to create something that, well, that actually works and works for decades. The secret? It all comes down to learning how to think in systems. So let's get into it. So, first things first, what even is a system? It sounds kind of technical, but it's really simple. A system isn't just a random pile of parts. Your car, for instance, isn't just a heap of metal and plastic. It's a system for getting you from A to B. A hospital is a system for providing healthcare. You see, the real magic is that all the individual pieces have to interact and work together towards one single purpose. That's the key. And here's where it gets really interesting. Systems pretty much always live inside of other systems. It's like a set of Russian nesting dolls. So take a concrete slab in a building. That slab is a component, or what we call a subsystem, of the entire building. But if you zoom in on that slab, you'll see it's also a supersystem made up of its own smaller parts: rebar, cement, gravel. Getting a handle on this hierarchy, seeing what's a system and what's a subsystem, is absolutely crucial for managing all that complexity. Okay, so you have this giant, world-changing idea. Where do you start? Well, not with a bulldozer. You start with an idea and, more importantly, a plan. This whole first stage is what we call systems analysis. It's all about nailing down what we're trying to do, why we're even doing it, and what the smartest way to get there is. And this process is super methodical, as it should be. First, you've got to define your goal. What does success look like? Then you face reality. What are your limits? Your budget, the landscape, the rules. And what are all the different ways you could tackle this problem? Next, you weigh the pros and cons of every single option. After you figure out the likely outcomes, you can finally make a smart decision. But, and this is a big one, it doesn't stop there. You have to circle back after it's all built and ask the tough question: did it actually work the way we thought it would? All right, the plan is locked in. Now we get to the fun part, actually turning that vision into a real physical thing. This is where we get into the nuts and bolts, and it's exactly why this systems way of thinking is so incredibly important. And here we bump into one of the biggest challenges out there: the huge difference between simple and complex systems. A simple or hard system, think of something like a pulley or a lever. It's predictable. You pull here, it lifts there. Simple. But a complex or soft system, like a city's entire water supply, that's a whole different beast. It has tons of components: pipes, pumps, treatment plants, but also people, regulations, funding. The interactions are messy and unpredictable. And it's constantly being hit by outside forces like a heat wave or a sudden population boom. You just can't look at one piece by itself. You have to understand the whole interconnected web. So the project is finally built. The politicians have cut the ribbon. Everyone's celebrating. But guess what? The work is nowhere near finished. A system has a life, a story of its own, and we have to understand how it's going to behave day after day, year after year. This leads us to this really cool field called system dynamics. And the big idea here is that the relationships between all the parts are often way more important than the parts themselves. How does one thing affect another? Are there delays? Are there feedback loops? It turns out the way a whole system behaves is often completely different than what you'd expect just by looking at its individual pieces. Let's make this real with a simple example from a rail system. This right here is a positive feedback loop, or a reinforcing loop. It works like this. More people ride the train, which means more revenue comes in. Awesome. That extra money lets you do better maintenance, which makes the trains more reliable. And higher reliability attracts, yup, you got it, even more riders. The cycle just keeps going, and success builds on itself. Of course, you can probably imagine how a negative loop could spin things in the opposite direction, right? Thinking about these long-term behaviors naturally leads us to the final chapters of a system's life. I mean, how do we keep these incredibly important systems going? And what on earth do we do when they finally reach the end of the line? As you can see, a system's life is this whole big circle. It all starts with that little spark, the needs assessment.
then moves through planning, design, and construction into its daily operations, and then finally into those super important phases of monitoring, preservation, and retirement. And here's the kicker, the real insight. It's in those first two stages, needs assessment and planning, where these massive projects are secretly won or lost. A bad plan or a misunderstood need can lead to epic budget overruns or even total failure years down the road, long after the last bit of concrete has been poured.
This quote, I think, just nails it. A systems engineer isn't just a specialist who's really good at one thing. They're a composite, a big picture thinker who has to pull in knowledge from dozens of different fields to crack the problem. They're the ultimate integrator, the conductor of the orchestra. And that really leaves us with a final thought to chew on. As our world gets more and more complex, the need for this way of thinking is just going to explode. We're talking about everything from sustainable energy grids to cities that can withstand climate change. The challenges are just massive. So the real question isn't just what we're going to build, but how are we going to build it so it serves us not just for a few years, but for generations to come.